Let's say A hat f sub j gives you back j times j plus 1 alpha times f sub j. So f sub j, since j, allowed values of j are 0, 1, 2, 3, and so on. So we say that, what are the eigenvalues? So a f0 is equal to what? What is 0 times 0 plus 1 times alpha? 0. What is a hat operating on f1? So that's going to be 1 times 1 plus 1 times alpha. So that's 2 alpha. 2 alpha f1. What is a hat operating on f2? It's going to be 2 times 3, so that's 6 alpha f2. What is a hat operating on f3? 3 times 4, so that's 12 alpha f4. So those are your possible outcomes, right? 0, 2 alpha, 6 alpha, 12 alpha, and so on. So let's say psi happens to be 1 over square root of 6 f1 plus 2 f2 plus f3. Okay, so what is our C1 here? 1 over square root of 6. What is our C2? 2 over square root of 6. What is our C3? 1 over square root of 6. Now, is psi normalized? What is C1 squared? Let's just verify that psi is normalized. What is C1 squared plus C2 squared plus C3 squared? 1, 6 plus 2, 6 plus 4, 6 plus 1, 6. So that's 6 out of 6. So psi is normalized. Okay? What's the expectation value of A? It's going to be integral of psi star A hat psi detail, right? Which is going to be sum of possible outcomes, A sub I times the probability of getting A sub I, which is C sub I squared. So what would that be? So it's going to be A1 times A1 times 1 over square root of 6 squared, right? Plus A2 times 2 over square root of 6 squared plus A3 times 1 over square root of 6 squared. So what is A1? A1 is 2 alpha, so that's your A1, this is your A0, this is your A2, 6 alpha, and A3 is 12 alpha. So this is going to be, note that we're ignoring A0 and A4 and A5 and others because the probabilities of those would be 0. The coefficients are 0. So this is going to be, what's A1? 2 alpha times 1, 6. What is A2? 6 alpha times 4, 6. What is A3? 12 alpha times 1 over 6. So that's the average value of A. Okay, so if you imagine you have a whole bunch of these systems, an infinite number of these systems, all having the same psi. Make measurements from each one of those systems, and you make a tally of all the outcomes. And this will be the average you'll get, which is going to be how much? Well, you can do that on your own. All right. What if psi is equal to F2? Same situation as before. What if psi happens to be equal to F2? What's the expectation value for property A? Psi star A hat psi equals F2 A hat F2, which is F2 A hat F2. What is A hat F2? F2, little A2 F2. Factor out A2, F2, F2, and that's just 1, so it's just A2. So we say property A is well defined. So it has a definite value. If psi happens to be an eigenfunction of A, what we're saying here is what? If I were to do A hat psi, I'm going to get A2 times psi, right? Because psi is F2. So psi is if psi is an eigenfunction of the operator, it has a well-defined value. What is that well-defined value? Whatever the eigenvalue is that corresponds to that particular eigenfunction. I'm sorry. So it's just going to be A2. And so in this case, what was A2? J plus 1 alpha. It's going to be 6 alpha. Okay, so if psi happens to be an eigenfunction of an operator, then if you measure the property corresponding to that operator, you'll get exactly what the eigenvalue is. That's the only possible outcome you'll get. So we say the property has a definite value.